Hey everyone, how's it going? Welcome to the Developer's Toolbox, a series where I introduce to you useful software tools to use with your projects both from within and out of your code. Because while it is important to be familiar and skilled in multiple programming languages, it's also important to be familiar with various tools that help you not only with the development, but also with interfacing with systems, creating or viewing test data, and many other things. And for this first video, we're going to talk about SSH and SCP. These commands are typically installed by default on your system, but if they're not, you can get them by installing the OpenSSH package. For Windows, you can go to Settings, Apps, and then under the Optional Features list, you will find the OpenSSH package. For Linux, you can use your package manager to install the OpenSSH package. Both SSH and SCP provide functions for accessing and interacting a remote system. SSH allows us to connect to the system to perform functions directly on it as a remote user. SCP allows us to copy files to and from a remote system. At a minimum, what you need to use these commands is the IP address and the user credentials of the remote host. For this demonstration, I have two VMs. I have my primary VM where I do all of my development, and then I have a second VM that will act as our remote host. In order for us to interact with the remote host with these commands, we need to make sure that the SSH server is running. So in order to do that, we're going to use the systemctl command to check the service that runs the server. This command will require admin level privileges. So the name of the service that runs the server is called SSHD, and the full command we use is systemctl status SSHD. This will help us check to see if it's running or not. And as you can see, it's currently not running. So we're going to use systemctl start in order to start the service. We'll check to make sure, and it's currently running. Okay, now for the command to connect to the host. We start with SSH, followed by the name of the user on the remote host, which for our system is a user. Now we need the IP address of the remote machine. To get the IP address of your machine that you want to connect to, you can use the command IP space ADDR. I added this extra bit here just to make sure I only show you this bit here so that you're not seeing a whole wall of text to try to find the IP address that I'm talking about. So we're going to connect to this one right here, 10.0.0.11. So we're going to type 10.0.0.11. So SSH a user at the IP address. Hit enter, and it's going to print out this message for us because we're connecting to this host for the first time. It's basically saying, hey, we don't know this host. Are you sure you want to connect to it? If we say yes, it's going to store this fingerprint into a file so that the next time we want to connect to it, it won't ask us this question. So we're going to say yes. Then it will ask us for the password of the remote user. And now we're connected. And I can basically look at the home directory of the user we're connected to. I can add files, I can delete files, I can run all kinds of commands and stuff. I could check to see the status of our server, which obviously it's running because we're still connected, but just to show you that we can basically run anything. See, it's telling us that the service on the server is active. Let's add a file too while we're at it. So we're going to call it remotefile.txt. I added this file with SSH. And if we switch to our remote host real quick and we check our home directory, there's our file. If we open it, there's the text. Now real quick, let's talk about the fingerprint that SSH asked us about when we tried to connect for the first time. What is that? Well, that's the identity of the remote machine. So when we store a fingerprint for a machine, it's basically so that our machine can remember it next time so that when you try to connect to it again later, it's going to ask that remote machine for the fingerprint and say, hey, like you have the same IP address that we used before to connect to you, but are you really the same thing? So that remote host will say, well, here's my fingerprint. And if the fingerprint matches, then our system would be like, okay, cool. Then that means I do know you, so we will connect to you. So where does it store these fingerprints? So there is a hidden folder in our home directory called SSH. And inside it is a file called known hosts. And it will store all of this information on it. Now we have all these entries here for this IP address, but the one we want to look at is this top one here. This is our fingerprint. So if I modify this last letter here, the I, to say a U and then try to connect to the host again, we get this warning. It says that, hey, we don't recognize this key. Like, we clearly connected to this machine before because the IP address is in our known host file, but the fingerprint we have stored for that IP address is not matching what this host is giving us right now. So it will prevent you from trying to connect to it. And the reason it does that is stated right here. It is very possible that someone might be pretending to be the machine you're trying to connect to. And the last thing it wants you to do is to accidentally connect to a machine that you probably shouldn't be connecting to. So if you ever get this message, just be careful. Check to make sure your server's okay. Check with the admin of the server to make sure nothing weird is happening. Whatever it takes, just to make sure that the server is okay. Now, there are some situations where this is just a false positive. There's nothing actually wrong with the server. It could be that the server had to be reinstalled. That will cause the key to change completely. In which case, once you've verified that, you can just go to the known host, delete the key. Honestly, you can delete all of these. Then connect to the system again, and it will say, oh, we've never connected to this before. Do you want to save the fingerprint? And you can connect to it again. But don't just do that blindly. Like I said, if something's wrong with your key, make sure that the host is all right. Make sure there's nothing malicious in between you and the host. Just be careful. Don't just blindly delete the key because you got this message. Always make sure that is in fact that the system is okay and it just had to be reinstalled or something. Now, typing in that IP address every single time you want to connect to the remote host, that can be very annoying. And in a situation where you have multiple remote hosts that you have to connect to, remembering all those IP addresses can also be very annoying. Fortunately, there is actually a very easy way to fix that. On both Windows and Linux systems, there's a file called the host file. It acts as a local DNS for your system. Whenever you do something network related, like pinging a machine, using SSH or something else, the first thing it will do is go to this host file to see if maybe there's a mapping for the host name you just used to an IP address. And if there is, it will use that. The host file is basically an IP address to name mapping. Something simple. So I'm going to edit it on the Linux system, but I will also show you where it's located on the Windows system. Because of where these files are located and because of what they do, they require admin level privileges in order to modify. So in Linux, it is stored in the etc directory. How you add an entry is you start with the IP address. You can add tabs, you can add spaces, you can do whatever as long as it's white space separated. It will be able to map the two together. And as you can see in these two entries here, you can actually map an IP address to multiple different names. But we'll keep this simple and we'll just call this SSH server. Now we're going to try to connect to the system again with our host name and the host file. Now, when we run this command, it's going to ask us for the fingerprint again. I'm not entirely sure why it does this, because as you can see in this line here, it clearly knows that the host name is mapped to that IP address. And we have an entry for that IP address in the known host file. But when we use this host name for the first time, it's still going to ask for a fingerprint. So we'll say yes. And we're logged in, as you can see. And when we go to our known host file, we now have a second entry that's basically the same as the first one, except instead of mapping it to the IP address, it's mapping it to the host name directly. Now I'm going to show you guys something cool. This is actually something that I've been surprised by many coworkers who don't know you can do this with the SSH command. And so I just want to share this with you guys so that whether you're completely new to these commands or you're somebody who has some experience with them but didn't know this, you will know it now. So we can actually send commands directly to the remote system without logging in by using the SSH command. So to do that, we start with SSH, our username at our host, then a space, and then we open up a set of quotes. They could be double or single, it doesn't matter. The reason we have to use quotes is because if a command is space separated and has multiple words, we have to make sure that the SSH command understands that this entire command is being sent to the server. Otherwise, it might get confused and assume certain things that you passed in were meant for the SSH command itself. For our command, we're going to say remove that remote file on the server, and we close the quotes. And you can have quotes inside of these quotes too. Just make sure to escape the quotes or to use the quotes that you're not using to capture the whole command. So we're going to hit enter. It will ask for the password. It won't give us feedback on the command actually being run, but if we switch to our remote server and we run ls, as you can see, the file's not there anymore. It's been deleted. So that's just a pretty cool thing that you can do with SSH, is sending remote commands to your server, which is useful if you're writing automated scripts in Bash. You can use those commands inside of the script, especially when you're trying to send commands to the system without having to manually do it yourself. Now let's talk about the SCP command. As mentioned earlier in the video, SCP allows us to copy files from one machine to another. So to show you how the basic command works, first I'm going to create a file on our local machine to be transferred to the remote server. And we're going to call it remote SCP file.txt. I sent this to server using SCP. And so for our command, we type SCP. The first parameter is going to be the file that we are trying to copy. And then the second parameter will be the destination we're trying to copy the file to. And if you want to rename the file in the process, you can. You simply just provide a full name for it. So to copy this to the remote host, we put in our user, followed by the host name or IP address, depending on how you're doing it. Then, in order to specify a directory in this machine where we want to put this to, we have to put in a colon followed by the path. And when it comes to the path, we have a few freedoms. As many of you may or may not know, a shortcut to typing in the home path is the tilde key. So if I were to type the tilde key on this local machine, that's the equivalent of saying /home/Crozo. On the remote server, it will basically be /home/a user. So we can type the tilde for this command if we wanted to specify a path, followed by /. And we're going to put this in the documents folder for a user. Now, if I just type it out like this, it may not understand that we're trying to put it into the documents folder. It might actually just transfer it as a file called documents. So it's always better to add that / so that it knows you're trying to copy it to a directory. If we want to rename it, which I think in this case we should, new remote file.txt. We'll call it something new when we transfer it over. So we're going to hit enter, type in the password to our user, and it'll show you the file has been transferred. So we're going to switch to our remote machine. So we're in our remote machine, and we're going to go to the documents folder. And there's our new remote file. And then there's our message. SCP is not restricted to just transferring one file at a time. We can transfer multiple files at once using the wildcard key. And that also means that we could transfer files by typing in a partial name and then the wildcard key, and it will look for all the files that match that and then transfer those over. We could also transfer a full directory if we wanted to as well. In order to transfer a full directory, let's actually make one. Remote directory. And let's move our remote file to the remote directory. And I'm actually going to add a few more files into this directory as well, so that I can demonstrate both the wildcard character as well as transferring the full directory to the host machine. I'll just use the touch command and just touch a few files in there. So first we'll show the wildcard key. So SCP remote directory, we'll say remote asterisk a user at SSH server. Oh, and another thing we can do is if we just specify the colon, it will automatically assume that we're saying transfer it to the home directory. So if I do this, it'll transfer all the files. And if I check the home directory in the remote machine, all 3 files are there. So if you just want to move files directly into the home directory, just add the colon at the end. You don't have to specify the path. It will automatically assume you want to put them here. Now we're going to transfer the whole directory over. So SCP, and like the normal CP command, to copy a directory, you have to specify -r, remote directory, a user at SSH server. I'm just going to type in the colon, hit enter. So it only shows it copying the files over, but if we go to the remote machine, as you can see, the remote directory is in fact there. And if we go inside the remote directory, all the files that were contained inside of it are there as well. Now, so far, I've only demonstrated doing all of this with just a single remote host. But what would happen if you have multiple hosts that you have to deal with? Never mind having to remember all the IP addresses or the host names for those machines. What about all the passwords for all the users? That's got to be really annoying too, especially if you're maintaining good password practices and making sure they're all different. So how do we get around that? Well, we use SSH keys. SSH keys are a public-private key pair where you have the private key stored on your own machine and you store the public key on the remote machine. And so when you want to use the SSH and SCP command on the user of a remote host, instead of asking you to use the remote user's password, it will try to authenticate you with a key. And if it can, then you can log in and do whatever. And you can share this key with multiple hosts, so you don't have to continue to juggle multiple passwords for multiple hosts, especially if you're trying to connect to a whole bunch of different machines at once, trying to do all kinds of things at the same time. So how do we generate a key? Well, there's a command that gets provided with the OpenSSH package. It's SSH Keygen. Now we can just run it with this command with no flags or arguments or anything, it'll work just fine. But there are 2 flags that you would more than likely use, and that's the T flag and the C flag. So lowercase t will allow us to specify the type of algorithm we want to use to generate this key. Now I'm not going to spend too much time talking about the different algorithms you can use. There's plenty of reading material online to help you decide which key you should use, and the default algorithm that SSH uses is RSA. The other flag we can use is the -C flag, -C, which basically is just comment. Nothing special, it doesn't do anything crazy, but it does leave a comment on the key so that when the key gets stored on the remote system, it will be stored with that comment, and people who are looking on the remote host and looking at the keys, they can see the comment and say, oh, this key is for this. So we're just going to say user creds. And it's going to generate it, and it's going to ask us where we want to save the key. Now, by default, it will save it to ID_RSA. So this is the default path. This is the recommended path to just save it to. So I'm just going to hit enter. Then it's going to ask for a passphrase. It is absolutely important that you enter in a passphrase to secure this key. The point of this key is not make it so you don't have to enter in any login credential information at all. It's simply to make it easier to log on to multiple machines. You should still have a passphrase for this key. It's important to do so to protect your private key and to make sure no one doesn't take it and abuse it and get into the systems that they shouldn't be getting into. So we're going to give it a key. And then it generates all this information and it completed the key. Now, how do we use this key on our system? Well, there's another command we got to run. SSH copy ID. And the only parameter that we really need to put in here is the username and host. So a user at SSH server. So it's going to ask us for the password for the server first. And then it's going to copy the key over. So now, when we try to SSH into the server, instead of asking us for the user password, it will ask us for the passphrase of our key. and then it logs us in. Now, with just one host, it doesn't really make much of a difference. We still got to remember a password. But like I mentioned earlier, if you've got to connect to multiple hosts with different users and they all have their own different passwords, which they should, that's good practice, that can get very annoying after a while. So having a key that you can publish to each of these hosts for those users to log into, this will make it much, much simpler because you only have to remember the passphrase for your key. And this key works with SCP as well. So if I SCP the remote SCP file over to a user at SSH server, it'll ask for the passphrase. One other thing to note, we can have multiple keys. We're not restricted to just the one. If you remember when we created that key, it asked where we wanted to save it as well as its file name. We're going to still save it in the SSH directory. You honestly should. That's where they should all go. But we're going to call it something different. In fact, as a real life example, I'm going to call it Ansible key. And we're going to leave the passphrase empty. This is a perfect example of a temporary key for an actual real life example. With Ansible, you have to provide it an SSH key so that it can perform its work on the remote host you're targeting in its playbooks. Ansible is a really cool tool, and it's something I'm going to cover in videos later on. But in order for it to work, you have to put SSH keys on remote servers without passphrases. And as a result, you would want these keys to only be temporary. You never want to maintain a key long-term that has no passphrase. So we're going to call this the Ansible key. I probably should have used the -c flag and called it Ansible. You know what? Let's do that. For Ansible. And we're going to say Ansible -key. And we're going to leave the passphrase empty because Ansible wouldn't work if we provided it a passphrase. And now we've got a key. And so we're going to copy that file to the remote host as well. So SSH copy ID. We're going to specify the ID -i dot SSH/Ansible key. Then specify the user and remote host. And it's going to see that we have a key already published with it. So it's going to ask us for the passphrase in order for us to log in rather than ask for the password of the host. So we're going to go ahead and authenticate ourselves. Oh. There we go. And we published a new key to the system. And if we want to test this key, SSH, we use the same flag as before, -i, specify the key we want to use. Now this is not going to ask us for a password at all because we didn't set one for this key. It will just automatically log us in. Now for normal logins, you would never do this. But for temporary stuff like running Ansible playbooks on a server, that's where you would use this. And so where does it store this information on the remote host? Well, there's a file in the .sh directory that gets created when we first publish a key to the system called authorized keys. And this is where it stores the public keys. This is all one line that's word wrapped. So if I highlight this, that's all one line. This is the key for our normal user login that requires a passphrase. And this one is for our Ansible key, where it doesn't require a login at all. So it stores both of these here. And so like with known hosts, we can delete these keys from this file if we don't want to use them anymore, which is good for when your private key gets compromised or stolen, then you want to delete the public key off the host so that they can't use the private key to get onto your system. And even though that example was just to show you how to make a temporary key to also publish to the same server, you can make multiple private keys if you really need to for different servers. Even though that can make things complicated, it does help you protect your systems because if one private key gets compromised, then at the very least, it won't endanger the rest of your servers because only one key got compromised. But let's say that was the case. Let's say you had multiple remote systems, multiple logins, multiple keys to maintain, all of that. That seems to be the segue for all of these things I'm about to show you. is, hey, let's say if you have this really annoying aspect with SSH. So there is a file we can store in our .ssh folder on our local system that allows us to save information on particular hosts that we have to frequently connect to. So I'm going to go to SSH and we're going to create a config file. It's just called config. Now there's all kinds of information we can put in this file for controlling our SSH connections without having to specify it every time we run the command. But I'm just going to focus on this basic stuff because all the other things is really dependent on what you're trying to do, and it would take too long to really go through all of them because there's a lot of settings you can put in this file. So I'm just going to focus on the settings you could put in here for hosts. Now, when you make this file for the first time and you try to use SSH, it may say bad ownership on the file. In order to fix that, make sure that the ownership permissions on .ssh, the directory itself, is 700, and that all the files inside the directory is set to 600, and then that will fix the issue. So to edit host entry, we're going to say host, and we're going to put SSH server. Now there are a number of settings we can put under the host entry. We're just going to put two. The first is the user, and we're going to set it to a user. And the second is identity file. And we're going to set it to, let's set it to the Ansible key. Just to show you, just to demonstrate. And I spelled identity file wrong. Just noticed that. I was wondering why it didn't turn yellow. So we're going to save it. Now that we have that entry in the config file, all I have to do is type SSH server. Then hit enter. And it's logged me into the user on the remote machine using the Ansible key. I have not had to specify a user. I have not had to specify any password or passphrase. All those things I have done has made it to the point where I just have to type in SSH and the host name, and I'm connected to the user on the remote system. Pretty cool, right? And you can add multiple host entries in there. There's all different types of files and settings you can put in there. So like say, maybe the SSH port on the remote system uses a different port other than 22. You can specify the port under that host entry. Now, the thing about that host entry in the config file is that name resolution doesn't get handled at that point. So if I were to say 10.0.011 with the SSH command, it won't read it. So it thinks I'm trying to connect as Crozo at that host. Well, Crozo doesn't have a login at that host. So, I guess that's a good point. I should have mentioned that earlier. If you just put an IP address, it's going to assume that the username you're trying to connect to is the same as the username you're logged into right now. So since I'm logged into Crozo, it assumes that there is a user Crozo on the remote host. So it couldn't resolve it. Now there is a setting we could put under here called hostname. And from examples I've seen, you can set it to the IP address, but that still doesn't resolve this issue. So if for whatever reason you want this to work with both the host name and the IP address, you have to create a duplicate entry of this, but instead of the host being the host name, you set it to the IP address. And I'll delete these host name entries as well. So if I do this, and now it just automatically logs me in because now there's an entry specifically for that IP address. This combined with adding entries to your host file, specifying multiple SSH keys and stuff, all this combined together will make connecting to multiple hosts, maintaining them and everything like that much, much easier. And that's pretty much it with these two commands. I pretty much covered the basics and I touched on a few slightly more advanced stuff as well, but there might be some more advanced things that I have not covered, mainly because they're not really things that I typically use with my remote systems. It's for like more advanced, more specific situations that you would use these stuff for. But if you are interested in them, there's documentation on them online, as well as people talking about how to use them and having their own tutorials on how to specifically use those things. I don't typically use them, so I didn't bother to cover them here. I wanted to cover primarily the basic stuff that everyone would use. But even if I don't cover all that advanced stuff, these commands are very powerful and very useful, and they're very easy to pick up as well. Because of this, knowing these commands are considered to be a very basic skill set that anyone working with computers should know how to use, especially when working with programming or something in IT. So I hope you've enjoyed this video and found it helpful, and if you did, then please hit the like button and leave a comment below to let me know what you think, especially if you think that I could have done something differently to make these videos better. If you want to see more, head on over to Wayfair Coding Academy channel to check out my other content, and while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you all next time.